Another find the inverse of a function. This one we could prove that it's one-to-one. It's not very friendly though, so we'll just make the assumption that this is a one-to-one function. And to find its inverse, we're going to get rid of the f of x notation and write it as y is equal to 2x minus 1 over x plus 5. And then the next step would change everything, where y's become x's and x's become y's. Alright, and then the goal here is to solve for this y. Well, first off, we want to get rid of the fraction, so we'll multiply both sides by y plus 5. So we'll get x times y plus 5 is equal to 2y minus 1. Distribute, and you get xy plus 5x is equal to 2y minus 1. Alright, now when we get down this far, we pretty much forgot what the heck we were doing. So we have to remember that we're trying to solve for these y's here. One of the y's is here, the other y is over here. So we need to get them on the same side of the equation. So the way I'm going to move it is I'm going to take the xy and put it over here. And while I'm at it, I'm going to get that 1 and shove it on the other side. So basically, the variable you're trying to solve for on the right, everything else on the left. So if we get that all straightened out, this would be 5x plus 1, adding the 1 over this way, is equal to 2y minus xy. Alright, and if we're trying to solve for y, notice it's in both of the terms. All I have to do is factor it out. So that'll give me 5x plus 1 is equal to y times 2 minus x. Alright, so let me bring my work up here. So we have 5x plus 1 and y times 2 minus x. Now, to solve for y, we're just going to divide both sides by what's next to it. In this case, 2 minus x. Alright, and then finally we're going to have y is equal to 5x plus 1 over 2 minus x. And lastly, we have to remember to change this y, this last y we end up with, into inverse notation. So to be f inverse of x is equal to this new function 5x plus 1 all over 2 minus x. And that would be our inverse of the original function that we have.